can. Yeah, it's audible. Great. So we are live. So it's go live button I have clicked. And yes, let us start it. So today we'll be studying gravitation chapter. It's very, like sir told ki from the previous classes, the gravitation chapter is going on. So as per in the continuation of this chapter, we'll start with this gravitation again here. Okay. Where is my pen? This is my pen here. So let's start it now without wasting time. None of the time must be wasted. Okay. So let us start it. Yes. All of this. Just wait a second. Shrishti BM, these are two students. What you are seeing here? Yeah. It's working, no. Okay, so let me do slideshow. Yeah. So students, here on your screen, the chapter gravitation. Okay. Here we start. Let me see if the polls are already made. Yeah, there is a very good poll here. So advanced poll, what does it say? I'm launching this poll. Please participate in this. We don't want to waste the time because time is really, really very important. Okay. So is my screen perfectly visible to all? Text yes or no. Yes, very good students. 6 students, all of you texted yes. Very good. Very intelligent. Okay. So we have started it. Fine. Yeah. Okay. You want me to close the video? It is in between. Okay. That's fine. I'll close it. So I'm ending this poll. Let me start the next advanced poll. I'm audible to all. Although I have checked, but because sometimes some students worry in between the sound is not coming. So for that, I have started this poll. Okay. Yes, I'm audible. Okay. And in the poll. I've entered the poll. Okay. Let us start the chapter. Students, I don't know what was going in the initial classes, but as per the official things, I'm starting with the thing which is to be started today. So today we'll start with interaction energy. Interaction. Okay. For you people, let us students see somewhat the previous things. Okay, you haven't studied the 12th chapter, no electrostatics. So we'll start with this. Okay, if I ask from any one of you in the class, so what does the meaning of interaction? Can anyone tell? Janvi Mandya, Rutuja, Janvi Chitradurga, Baleri, Shrishti, anybody? What is the meaning of interaction, students? Interaction ka kya matlab hota hai? What is the meaning of interaction? Interaction. It means, that there is some exchange of material or energy between the two particles, or forces are acting between two particles. This is known as interaction. It gives you the physical significance of the word, which is interaction. Okay. But when I call for this chapter, that is when two masses are there and the gravitation chapter, this interaction is basically, it can be more properly and precisely can be written as what? Gravitational potential energy. Gravitational potential energy. This is gravitational potential energy. Remember it always. Okay. Up to here, is it clear? Please raise your hand, students. See, I will not ask again and again. Please raise your hand. Please raise your hand. Please raise. So when I will say please raise, so raise. Otherwise, I'll go. Okay. For the further topics. यहाँ तक समझ में आया? Yes or no? ठीक है. See now, students, what happens? Very good, Baleri students. Very good, intelligent. Okay. Suppose students, we are having a mass m1 and you're having other mass as m2. Okay. And these both masses are brought closer to each other at a distance r. Check. Now suppose we know this thing, the gravitational force will be acting on both of them, and the gravitational force is attractive force. So we will say that on this mass, the force will be acting as with this minus I cap. Attraction, x cap is this. I can write x cap as I cap also. Minus x cap is this. I can write this as minus I cap also. Fine. Okay. So this force is applied by the gravitational field of m1 to m2. So what we will see this, if I keep this m1 mass in a static mode, Mr. Static mode. It means if it is not allowed to move, and this is free to move. So what's going to happen? If I just observe the dx linear motion movement of m2 mass, this mass will move dx here. So now what's going to happen? I mean, if F force is acting and dx displacement is there. So when I see this, I'll find this is F dx if multiplied. So this gives me work done. Okay. So what we're going to do is this: if it's further displaced by distance dx, we have the work done by the field that is given by this formula. So when I put this full formula in this, I'm getting the answer like this. Okay. So when I do integration, see, integration will be how? It is like this. If I bring this mass m2 from infinite to this position at r distance from m1, where m1 is fixed and m2 is, it's of show. It's of course, it's a common sense. It's freely moving mass. Okay. So when I integrate from infinity to r position from m1, I'll get ultimate answer by putting the limits at the end as this positive work done. Okay. So it gives me like this. This work done is by what? This is work done by the field. Okay. But we want what? We want the work done by us. Remember it. During the process field of system, this positive sense is the amount of work done. Okay, by the field. But for us, remember students, I'm doing this switch on. I'm on this video. Remember always, you will never use the formula plus gm1 m2 upon r, because that is for the fields. But we have seen this thing, gravitational forces are attractive forces. So here we'll write here negative sign. Remember reason, because gravitational force is attractive force. So we'll write here negative sign. Okay. So this formula you will use as an application formula throughout all your NEET questions from this gravitational topic, or your JEE NEET, JEE mains and advanced questions, or KCET, or if you solve some Avanti models. Fine. I hope the thing is clear to you. Yeah, so many good students have joined. Trishna have joined. Very good. Very good. See this now. So this is the formula of the gravitational, Mr. Gravitational interaction energy. Gravitational interaction energy. La, 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 la. And this is what? This is gravitational interaction energy. Okay? I hope it's cleared. Students, please raise the hand. अब आपको करना क्या है? What you need to do is this. Just remember this formula throughout the session. Star, 5-star. This is 5-star hotel. This is 5-star rating. I'm giving this 5-star rating. Okay. This formula is 5-star rated. Remember this. Anybody is facing any doubt in this formula, please raise your hand. If you're not facing, text, sir, move for the next slide. Like write like this. Sir, go next. Go next. Students, if you will not reply, then session will be not interesting. No. Reply. 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 Okay, I am going then. If you don't want to reply, I don't have any issue. Okay, some of you have replied. Chitradurga says that her voice is cracking. Maybe it's from your side. I don't think so, because voice is very much clear here. I'm using very high quality, and things there, Okay, so Baleri said it's clear. Thank you, Baleri students. Chitradurga, please see your, instruments. So now let us move. Okay, so we have studied one thing, interaction energy between two masses when are kept at r distance, like m1 and m2. The interaction energy is given as minus g m1 m2 upon r. Okay? So use this formula. There is no breaking problem. I myself am hearing this thing. You can use the earphones. What's the issue is? Is there an issue? I think the voice is clear. Okay. So students, I have already asked from, from the starting of the class, voice ka issue hai to batao pehle hi. Now you people are seeing me. Okay, students. So based on this formula, solve this question. The question says like this. There are three particles, each of mass m. This is m mass, m mass, m mass, and they're placed at the corners of equilateral triangle. When we say equilateral triangle, it means all the sides are equal. Angle between the sides is 60 degrees, 60 degrees, 60, 60 degree. Okay. Now they say that at first calculate the potential energy of the system. Okay. Next what? Then they say work done on the system if the past side of the triangle is changed from D to 2D. So there are two parts or two sub questions from this main question. We know the interaction or the gravitational potential energy of the system of two particles. But here is the system of 1, 2, 3 particles. So just we need to write the formula properly. Okay. Don't count the pair twice. Just remember this point. The concept is this, where you can be mistaken, that don't means don't, no means no. Don't count the pair masses twice. Okay. Suppose you count this, again you're counting with this back. No, don't do this. Okay. So solve this question. A part, it's very easy. The printed format is on your screen. I hope Jinvi Baleri students can solve. And Jinvi Chitradurga students also. Trishna solved, Ratuja solved, Nama solved, Mandya solved. All of you students try to solve this. It's an easy question. See, if you solve the questions, no, then only your level will increase. Otherwise, you will, I think nobody can reach anywhere. Applications are very, very important. Please solve it. I'm giving you the time. Find the interaction energy first, then increase the side of a triangle from D to 2D, then find the net interaction energy. Okay. Solve it. You're given 3 minutes. Have you solved, students? Okay, so I am solving this for you. Okay, see it carefully. Just watch it carefully. I'm solving it for you. Simple hai na yaar? Write the interaction energy to system of particles. Again, write the interaction energy of the two system of particles and solve it again and again and again. And you will be able to solve it properly. Okay. So don't panic in these kind of questions. These are easy. Okay. Understand this thing. These are what? These are easy questions. Hold on, students. There are some network issues there. Okay, now I'm solving it. Okay, 1 second. So see here carefully. Yeah. See, students, suppose I'm solving it now. Be very careful, okay? Don't see here and there. Suppose you are having two masses, M and M. And suppose these two masses are at D distance. Like this. I want to write the interaction energy of this two system of particles, just use the generalized formula. Okay, one student is given the answer. I don't understand how the voice is not clear. Why you people are again and again texting you? See, Here all the connections are fine. Okay, don't interrupt the session in between. Okay, like we can see it, like it's audible properly. So suppose you are having two masses m and m at a distance d. So interaction energy of system of two particles, that is the gravitational interaction energy of the system of two particles, is given like this. Thank you, Belarus students. So Belarus students can hear, that's fine. Okay, that's so nice. So minus g m square upon, very good. This is for d. This is interaction energy of this system of particles. Now, if we focus here, this is same as I have made for one. So how many pairs we are having? One, this, three. So write the answer. Final or net interaction energy will be minus g m1 m2, that is same, upon d, plus में again 1 minus d, plus में again 1 minus d. So this will give us minus 3 g m square by d. This is the interaction energy, which is the answer of the A part. Okay, that for this configuration, write the gravitational potential energy or interaction energy that we have written. There is no problem now. But if we see now the B part, students, the B part says like this: work done on the system if the size of the triangle is changed from D to 2D. What does it mean? It means if you extend this side from this to very much on both the sides 2D and make a big triangle, now what will be the work done? Simple. We know this thing, work done is minus of the change in potential energy. Or if you want to extend it to, or just expand its origin, I mean, you just make it delta, big size. So D is infinitesimal small. This is big one. So work done is equals, change in work done is equals to change in potential energy ka negative. Okay, simple. So work done will get as what? That is final potential energy is what? At 2D sides of equilateral triangle. Change minus initial is at D. So we are already having the interaction energy at small d distance, which is equals to minus 3g m square upon d. And now we need to find at 2D distance for the same, I mean, if the equilateral triangle is having 2D distance, then what will be the interaction energy? So that we need to find now. So this is M, this is M, this is M. Okay. So again, the answer will be what? That at 2D, the potential energy will be, at 2D distance, the potential energy will be minus 3 g m square, and distance will change to 2D. So now we have this also, we have this also. No need to write delta again here. Okay, so I would just erase this. Delta bye bye, delta bye bye, delta bye bye, delta bye bye. So here I will write this is minus. So I'm having U2D, I'm having UD, put this here. So work done I will get as minus 3 g m square by 2D. ठीक है, minus 3 g m square by d. So this will give you final answer as what? क्या मिलेगा? Will give you plus 3 g m square by d half plus 1. ठीक है, because minus and minus will come out and become plus here. So net work done will come out to be, it is 3 by 2. So it's 9 g m square by 2d, which is the work done. Okay, so this is your final answer, students. Acha, hold on. Here's one mistake. U final means U initial, no, minus hai. Minus either bhi hai, either bhi hai. So this will be plus. So this will be minus. This will be what? This is minus this is plus. So this will be plus half. So the answer will be somewhat changed, students. Okay, let me erase this. I'm sorry for this. So answer will come out to be, the work done will be equals to, it is minus 3gm square by d, okay, minus half plus 1. So net answer will be minus 3gm square by d half, okay, and this is net work done minus 3gm square by 2d. This is the answer, students. Okay. So this is the B part's answer. First part answer was what? Very simple. At d distance, potential energy is minus 3gm square by d. So we have written both the answers. Anybody is facing any doubt in this first question solution based on the interaction energy and the gravitational field? Any one of you? Please raise your hand or give a text in the chat box. Reply in the chat box, students. Reply in the chat box. Okay, no one is replying. Let us move next. Okay, now this question, it's a class illustration. You have to solve its same. Dekho, jelly binary students, interaction energy is nothing but what? The energy. So suppose I talk about the interaction energy of two particles. Suppose you're having a mass m1 and you're having a mass m2. Okay? You're having the mass m1 and you're having the mass m2. And these two masses are at r distance. So interaction energy between these two particles will be what? If these two masses, that is m1, m2, are fixed at their positions, and this is the configuration of two system of particles, so there will be some energy which is associated with it, which is like a potential energy, which is keeping this configuration as fixed. Because see, there will be attractive forces, so they must move. They're fixed, maybe they are in some static condition by an external agent, but whatever, there will be some energy of configuration associated with it. So such energy of configuration which is associated with these two masses is known as gravitational potential energy. Okay, and the formula is minus g for two masses, it is m1 m2 upon r. Okay, so this is, students, a class illustration. You have to solve this question here only in the class. No relaxation will be given. I will write the question, little bit explain you how to solve it. I'll give you the interpretation, simplified one, and then only you have to approach by yourself and solve this question in the class. So it says two particles. Okay, one of the students have texted. Very good, Bellary students. So two particles, mass m1 and m2, are initially at rest at infinite distance. Suppose m1 was, okay, what you're doing? Very good. m1 was distance and very much very much long distance, infinite. So find the relative velocity of approach due to gravitational attraction when this separation is d. So what's going to happen? We know this thing. When the two masses are at a very far distance, such that a distance r between them is infinite, since there is some attraction force, that is the gravitational attraction force here. Okay, listen, attraction force, that is the gravitational attraction force, which is having the formula like g m1 m2 upon force kya hoga? It's r square, students. Okay, so now what can happen? This mass will be feeling the force here like this, and this m2 will be feeling the force like this. So in the future, after some time, these two masses will be at a particular d distance. So this is m1 mass This is what M2 mass of separation between them. है ना? It's sure because attraction is there, so they'll be moving, having some acceleration. So see what's going to happen now. So they're asking you कि if on a particular particle the force is acting, if the force is acting, there will be also an acceleration of this particle. If force is acting, there is an acceleration, sure, the velocity will generate. The velocity will generate. Okay. So for both of them, there will be some velocity here. Iski velocity V2. So they're asking you the velocity of approach, relative velocity of approach. What does it mean? It means VR is equals to V1 plus V2. This you have to find. So what is the approach? Approach is this. First, you will find V1 value, then V2 value, then you will add this both value, and then you will get the final answer, which is the requirement, the demand of this question. So your time starts now. Solve the question, students. I'm giving you 4 to 5 minutes for this. It's an important question. Then we'll start the orbital velocity and escape velocity. At least solve the value of V1. Rest question I'll give you as a homework. At least solve the value of V1. Rest of the question I'll give you as a homework. Students, find the value of V1. Okay, so I'll solve it for you. Okay, I think it's a big question. So let us start. See the approach. It's a very, it's above average question. So suppose we're having a mass M1, okay? And there is some other mass which is at, let me erase this. You're having the mass M1 and at a far distance, that is infinite, you're having the mass M2, okay? So what's going to happen when the forces will be acting on these masses, they will gain some speed, okay? And finally, they will be at this location and will be having de-separation between them, okay? So let us write, because none of the external forces are acting. All the forces are internal forces. So I can conserve the energy. So I will apply here conservation of energy. Conservation of energy. Because non-conservative forces का work zero है यहाँ पे, okay? The work done by the non-conservative forces is zero. So when I will apply this, I will write like this. Suppose it gains the speed V1 like this. Starts from zero speed. Both of them are having, both of the masses M1 and M2 are having the initial speeds as zero. So finally they will achieve some speed like this. So I can write the formula half mv1 square, half mv2 square, and potential energy will be minus gm1 m2 by d equals to 0. So final energy, initial energies, final kinetic potential, initial kinetic potential. Okay? Remember, initial kinetic energies are zero. Some of them will be zero, but potential energy is still zero, because if I put minus gm1 m2 upon r as infinite, infinite means 1 upon 0. So 0 will go up, 0 into something is 0. Okay? आपको मिला ये value. ठीक है? Now also you can see this. Here no external force is acting on the line of action or the movement of these masses. So I can conserve the momentum also, because we know this thing, students, कि external force is given as dp by dt, where p is momentum. If external force is 0, so we can say momentum will be constant. So conserve the momentum. When I will conserve the momentum, students, so what's going to happen? You'll get this value, that is m1 v1 equals to m2 v2. Okay? So you have this second expression. First expression is this. Use, so this is your homework. You'll get the complete answer. We are having two equations and variables are how much? V1 and V2. So it's our, now it's not complicated. It's simplified already. V1 and V2 are variable. Rest all the things are given. We are having two equations, two variables. Just do the manipulation, simplification. You'll get the values of, this is your homework, okay? You'll get the values of V1 and V2. Once you get the value of V1 and V2, what you need to do? Just add these values like this. You'll get the answer, velocity of approach. Okay? Students, I hope that you got an idea. Students, I hope you got an idea. Okay, very good. Now let us approach next. Let us talk about a very interesting topic, that what happens to the G value, which is known as, which is a very world famous value, which is accepted by the international physics system, which is known as acceleration due to gravity. This is what? This is acceleration due to gravity. Okay. We know this thing, ki it is given by what? We know ki suppose if I am standing here on the planet Earth, on the surface, okay, and I am having the mass small m. So between the Earth's center, I mean, you can treat the Earth to be like a sphere, and at the center, all its mass to be concentrated. So like a center of mass concept. The concept would be like this, ki there are two masses, capital M mass, small m mass, and RE is the distance. Okay? So force between these two, which is the gravitational force, we already know it is Gm mass. I can write this at the denominator. I can use the symbol as, what symbol I can use? I mean, this is like, okay, mass of the Earth. M, distance is RE, so RE square. Now remember, this G is nothing but force we know is mass times acceleration. So we'll write my mass and acceleration. Because I am small, I'll be able to move, okay? So this will get cancel, and this acceleration is nothing but G only, students. Remember this. That is acceleration due to gravity. Okay? So this is how, ये है कि ऐसे आता है ये formula. This is the way why this formula comes, okay? Okay? I hope it's clear. Now, students, what happens to this G value if I leave the surface of the Earth and I just, you know, move towards the value at a height h above the Earth's surface? Okay. So at this point, if I'm standing, I'll feel the G value to be GME upon the net distance from the center, that is RE plus H का square. Okay. Now we will do some mathematical manipulation, that is binomial expansion. So I can take from this common RE square. So this will give me 1 plus HRE. Okay. And this will go on the upside. This is the G value at height h. And this I can write as, by binomial theorems, -2. So -2, I can treat that a radius of the Earth. Okay, I can treat the difference between these two distances as like, I mean, it's very, very high. Okay, so I can approximate the value to be that GH, that is for a mass at a height h from the Earth's surface, This is GME upon RE square, same. 1 minus twice of H upon RE. Remember this value, students, very important. And this we have already seen in the beginning slide. This is G on the earth. So G, if you go at a height H from the Earth's surface, remember, this is very important. You'll find in the resonance sheet, you'll find in the Avanti module, you'll find in the HCV, you'll find in the previous year questions, many of the questions based on this formula. So this is G on the Earth, 1 minus 2, height at which you are from the Earth's surface upon radius of the Earth. So this is how G changes if you go height H from the surface of the Earth. Please note it down. Is it clear? Bellary students, please raise your hand. Chitra Durga, Namma Mandya, please raise your hand, students. We are here waiting for your responses. Please raise your hand. Okay, very good. Chitra Durga students understood everything. Good. Now, next is this. If on the surface of the Earth, at R radius from the center of the Earth, G is GME upon RE square. And if you go height H from the center, from the surface of the Earth, the value of G is equals to G1 minus 2H upon RE. So what's going to happen if we go deep inside the surface of the Earth? What's going to happen if we go deep inside the surface of the Earth? Okay. So for that, let us see this topic now. Yes. Suppose this is the surface of the Earth and the person is standing. Suppose I am standing here. If I go deep inside this, like this at H, if I go deep inside like this, so what's going to happen? What will be the value of G now? So इसके लिए भी एक derivation होता है. Derivation is like this, students. G inside will be given by this formula. If you see the X distance from the center, X will be RE radius. This is X. RE radius minus this H quantity. Okay. Just remember the formula for this. So finally, we'll get this answer that G varies. If you go depth D from the surface of the Earth, inside the Earth, the acceleration due to gravity varies as this. This is same surface on the G on the surface, 9.8 meter per second square. Somewhere you will find as 10 meter per second square. 1 minus H upon the radius of the Earth. Okay. So let us write the three formulas. Formula number 1. When a person is, let us laugh. When a person is standing on the surface of Earth, okay, G value will be 9.8 meter per second square. And suppose when the person goes a height H from the surface of the Earth, then the G value will be what? This will be what? G 1 minus 2H upon RE. Okay? And suppose when the person goes D depth inside, then G value will be what? G value will be G1 minus H upon RE. So these are the three formulas on your screen. I've written a rough sketch of these formulas. Okay. Ho gaya? Did you understood this? Now remember these formulas. You'll find many questions. Okay. Or oh, nobody told me the camera. The audio is off. None of you told the audio is off, students. I'm asking, did you understood these three formulas? By mistake, the audio got off. Okay, technical issue. It happened. Okay, now at the last, we'll see the orbital velocity and the escape velocity. Let us see it. So let us first understand, what do you mean by orbital velocity? What is the meaning of orbital velocity? Okay. Suppose students, suppose we are having the Earth planet here. Okay, let us sketch it properly. Let me use the highlighter. This is blue planet, so somewhat blue here. Because Earth is 1/3 with the water, or I don't know, maybe more. And then greenery we need. So greenery is by this. Yeah, this is the planet. Okay. Suppose if a missile or like something, a space kind of instrument is being projected from the Earth's surface, and when it goes up and it is revolving in a particular trajectory like this, what it is doing, it is revolving in a particular trajectory. So for this missile to revolve in a particular trajectory, we must understand like this: it must be given some minimum velocity. This must be given some minimum velocity, which is known as orbital velocity. Which is known as what? Orbital velocity. Okay? Orbital velocity. Fine. So the definition says same, that orbital velocity is defined as the minimum velocity a body must maintain to stay in an orbit. Okay? We'll not go in the derivation now, but we'll just understand the formula. I mean, we'll just remember the formula. The formula says like this: velocity of orbit, or the orbital velocity, is given by this formula, g m by r. Okay. Suppose, let me show you. Suppose this is the radius of the Earth, r, and this is projected like this. So I can say half mv square is equals to g mm by r. Okay, compare these energies: kinetic energy and the interaction energy of the Earth and the missile or your spaceship, and this will cancel. Okay, and we get the velocity as, oh, there is some mistake here. Oh, no, not this. We'll not write half here. Yeah, okay, fine. So it is at a h distance, no? Yeah, hold on, students. There is some mistake here. Okay, we'll compare like this. So listen, we'll compare like this. Just compare the centripetal acceleration and the force. Okay, so mv square by r, speed v is the speed with which this missile is projected, and rest is the force. Okay, you will get the v orbital velocity as under root gm by r. Okay, fine. So this is the orbital velocity. Now we'll see this velocity, that is escape velocity. So what is the definition of escape velocity? See, if you give, see, again, I have to draw that thing. Okay, students, so see, suppose we are having the Earth planet like this, okay? See, if you didn't understood the orbital velocity, you will understand now. And this is what? Blue. So let me color this again. And green color, here we are having. Okay. Suppose if you project, See, please don't go. Okay, understand this. Radius of the Earth is RE. If you project some missile or some kind of space shuttle, okay, kind of thing, so that it must be surrounding the Earth, it must be revolving around the Earth in a particular orbit like this. It must be revolving around that in a particular orbit. So for that, you must give this missile the velocity which is known as orbital velocity, and the formula is under root gm by radius of the Earth, where capital M is the mass of the Earth. Okay? But if you are projecting a missile from the surface such that you want like this, this must escape the gravitational field of the Earth only. That this missile must go forever, 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 and escape the gravitational field of the Earth. Because see, Earth will be attracting all the particles towards it up to a certain range of the field, which is known as the gravitational field range of the Earth. Okay. So for that, if you want this missile to escape this field of the Earth, velocity which you must give is by this formula, and the formula is under root 2gm by re. So these are both easy formulas. This is escape velocity. Okay? This is what? Escape velocity. I hope you understood. Please, students, raise your hand. I hope you got an idea of both the formulas and the definitions too. I hope you got the idea of both the formulas and the definitions too. Students, please raise your hand. Students, please text in the chat box if you understood this. Okay, so there is one homework based on this. So you have the formula of the escape velocity, and the question is this: suppose the planet is now not Earth. Okay, the planet is Jupiter. Okay, and the radius of the Jupiter is given as 7149 kilometer. Kilometer means 10 to the power 3 meters. And the mass is this 1.89810 to the power 27 kg of the Jupiter planet. And they are now asking for a particular missile, find the escape velocity. So the formula you will use same, that is escape velocity is given by two formulas, 2gm by r. Use this basic one, okay? In the next class, you will see the different one. So this is 2gm by r. Mass of the Jupiter you will use, which is given here this much. And radius of the Jupiter you will use, which is given as this. So through this, you'll find the answer. Okay? Students, I have to end the class soon now. That's why I'm just giving you an overview of this. Next, suppose they ask you the orbital velocity. So for orbital velocity, you can use this. Suppose again that a satellite is to be launched from the Jupiter planet. Okay. And it must be set at a particular orbit to be revolving around the Jupiter. So they're asking you the velocity. So such a velocity, remember, it will be what? So whenever there is a revolution of the revolution of the satellite around the planet, so that velocity which you will give to this satellite will be orbital velocity, which is given by the formula very easy, under root g mass r. In the class we have seen mass is the Earth, but here the mass will be of Jupiter. So we'll write here the mass is what? Jupiter. Radius is what? Jupiter here. Okay. So mass of the Jupiter is given already here. Radius of the Jupiter given already here. G value is given. Just put the values. These are just value based. Okay, students. So I have to end the class soon today due to some technical issues. I'm launching a poll here, students. Okay, please participate in the poll. I have launched the poll. I hope you understand the things. Let us summarize side by side. I have given you the poll. The summary is this. We started with the interaction energy. Okay, we started with the interaction energy, which is known as gravitational interaction energy. how the G changes with the height. This is how the G changes with the height. See this. Okay. Hold on. Yeah. So on the Earth, it is this. Height h, it is this. Inside, it is this. Okay. At last, we have seen the orbital and escape velocity. Simple. So orbital is to set a satellite in a particular orbit around a planet. Escape is that this satellite gets escaped from the gravitational attraction of the planet. It can be Jupiter, Saturn, Venus, Neptune, Earth. Okay, we have seen a basic case of Earth while seeing the formula. So students, these were all things we have already seen now, and thank you so much for your participation in the class. Okay, you kept, I mean, you were really interested in studying, so this will benefit you. Okay, so students, I'm ending the poll. I have ended it. Okay, bye bye everyone. Take care, study well. We'll meet in the next class. Be happy. Okay, so next class, most probably Sham sir will take it. Okay, bye bye everyone. Thanks for attending the class and keeping patience throughout. Okay, so bye bye everyone. I'm ending the class. Bye.